Okay, so today we continue with sets and performing set operation. And what are the operations in sets? Is basically knowing whether we're using intersection, the union, or the composite of a set. Right? So the example one, right? So they want us to find composite of the set P given the universal set is 1, 2, 3, 4, 5, 6, 7, and P is a set 1, 3, 4, and 7. So what you're really asking for is a set P prime or P composite. And what this means is all the elements that do not belong in the set P. So one way of doing it is crossing it out from the given set. This is a fast way, right? That way the remaining terms or elements will what will be outside the set P. And that's the answer for that there. Example 2, if we are given the set 7, 8, 9, 10, and 11, and they ask us to intersect it with the set 6, 8, 10, and 12, this is where knowing or understanding what the symbols are and what they mean. So intersection means common elements. So what are the common elements? We have 8 and we have 10. So the intersection set would just have the elements 8 and 10. So what they would normally say is if this is the set A and this is the set B, A intersect B. That's how that is written out with it. Example 3 is also intersection 1, 3, 5, 7, and 9. Again, let's call this set P. They want the intersection. Let's call this a set Q. 6, 8. Sorry, not 6, 8. Undo. 2, 4, 6, 8. 2, 4, 6, 8. You can see that there are no common elements. So anytime there are no elements in a set, is an empty set. So P intersect Q is an empty set. So it's either we write it like this or we put a brackets with nothing in the middle, right? Example 4, we have 1, 3, 5, 7, 9 intersecting an empty set. Well, an empty set has no elements. So this intersection will also give us an empty set. So if we say the first set 1, 3, 5, 7, 9 intersect the empty sets. So that again we could label it. So A and B, the intersection of A and B would also be an empty set because there are no elements in B. Number 5, they want the composite of G given the universal set and they set G. So if this is a universal set, K, R, Y, H, Z, and B, and G is R, H, and Z, and we want the composite of G. Again, it is the easiest thing to do just to cross out what elements in G. So R, H, and Z. So what we remain with will be the composite set. So K, Y, and D. 6. Now the upside down intersection sign, with the sign looking like a U, is union, and union means to unite. So 7, 8, 9, 10, 11, union 6, 8, 10, and 12. Right, so again, if you label it A and B, and we say A union B, this set will be all the values. So we have 6, 7, 8, 9, 10, 11, and 12. Now note that even though this set has 5 values and this set has 4 values, we do not get 9 values because we do not repeat the values. So we have 8, you'll write it once. We have 10, you'll write it once. Right? So that's the only difference. So example 7. 1, 3, 5, 7, 9. Union, that's not a union, that's a U. Union 2, 4, 6, 8. So again, if you call this P and we call this Q, the set P union Q will be equal to all the elements. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Example 8, we have set 1, 3, 5, 7, and 9, union, an empty set. Now, if we call this P and we call this Q, P union Q would give us 1, 3, 5, 7, and 9. Now we have to note that this and this is exactly the same. So if we were to use only set notation, right, we would say that P union Q is equal to P, because P and this is exactly the same or the equal. We have number 9 and 10 here. Example 9. L, M, K, T, O intersect O, K, L. Now, it doesn't matter the order that it's in. You're just going to write the common elements, because intersection has common elements, right? So if this is the set, let's call it L. L is in the set. So let's call it the set X and the set Y. X intersect Y will give us the elements O, K, and L. Right? Now we can see OKL is the same as the set Y, as this and this exactly.
Good afternoon, sir.
Good evening. So X intersect Y is equal to the set Y in this case, and this is in set notation. So sometimes in multiple choice you'll get that. Example 10, we have 5, 7, 8, 9, 10, union 0, 1, 7, 9, and 10. So again, if we call this A, we call this B, what they're asking for is A union B. And we're just going to write all the elements. So 0, 1, 5, 7, 8, 9, and 10. Now remember, even though we have 9 here and here, we write it once. And also the same thing as 10 for 10, write it once. So solving problems involving Venn diagrams. So solving problems involving Venn diagrams. Now, remember Venn diagram, the universal set is represented by the rectangle. And then we have the number of subsets inside the universal set, right? So how we label it again? Universal set. Let's call the set A, call the set B. Now, if we watch the note on the left-hand side, it is say n, or the number of elements in A union B is equal to the number of elements in A add to the number of elements in B subtract the number of elements in A intersect B, right? So let's give each one of them a color. So let me say number of elements in A is red, number of elements in B is green, and number of elements in the intersection is blue, right? So the intersection is here. The number of elements in A would normally be the whole set, and the number of elements in B would normally be the whole set of B, right? Now, what I want you all to understand is that n, or the number of elements in n, the universal set, right? So if this is a universal set and the number of elements in n, right, let's put it in purple, will contain everything in the rectangle, right? So you have to remember that. Now, what does this mean? The number of elements in A union B. So if I was to shade that, let's shade it in gray, A union B would be the two circles only, right? So let's say an example, the universal set, or the number of elements in the universal set, is 30. If the number of elements in A is 15 and the number of elements in B is 17, right? And there are no elements outside A and B, right? We could find, let me say, if A, or the number of elements in A union B is equal to 30, right? We could find how many elements are in the middle. So how am I going to do that? Let me show you. So this is here is a formula. So this here is like a formula, right? Oops, went too far. So if I had the table or the diagram, right, and we know the number of elements in N is 30, and the number of elements in E is 15, and the number of elements in B is 17, right? we need to find how many elements in here. Now, the formula says the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A minus B. So the information they give us, we have this, which is here. So let's write the formula. N A union B, the number of elements, is equal to the number of elements in A, add the number of elements in B, subtract the number of elements in the intersection, A intersect. Right, so you want to find how many students in both sets. So this value is 30. The number of elements in A is 15. Add the number of elements in B is 17. Take away, and we don't know what this is, so let's call it X for now. Right, so 30, 15 plus 17 is 32. Right, and remember how we do algebra. If you want to solve for X, we'll carry the 32 to the left hand side. So we'll have 30 minus 32 is equal to negative X. And 30 subtract 32 is negative 2. Is negative X. And the number in front of the X is 1. So we divide by negative 1 to make it a positive. And anytime we divide on the right hand side, you must divide on the left. So negative 2 divided by negative 1 is positive 2. And X is equal to 2. So if we were to draw the Venn diagram, right, and label everything, inside here we will have 2. And the remainder, the A only, will have 15 subtract 2, which is 13. And the remainder for B will be 17 subtract 2, which is 15. And if you add it up, you should get 30. So 13 plus 2 is 15 plus 15 is 30. So this is correct. That's how you test it. Right? So number 2, we have a formula we have to learn. A intersect B prime. This means the elements in A only. Now, let me replace this diagram. Right, so this is the diagram with A and B. Right, so A only, what does that mean? So let's work it out. We have the set A. So if I was to color the set A, right, you'll have that. Now, everything outside of B, so I'm going to use lines. So B prime is everything outside of B. So this would include parts of A, but not the whole thing. Because from the previous example, we know that we had some overlap, right? So what we can see is that the intersection is a common element. So what will be the common element? That's the wrong color to use. Let's see, gray would work. Nope. All right. Use white. So this will be the common element. And this would give us basically the elements that in A that do not belong to the set B. So that should be here. Right, so I outline it in black. Right, so A intersect B prime will give us A only. Now similarly, if I was to do it where B intersect A prime, this would give us B only. Now Now these three formulas are very important for us to go forward. Right? Remember, intersection is associated with and, union is associated with the word or, an expression. Now in algebra, any expression does not have an equal sign, and an equation has an equal sign. So if they ask you to write an expression, then we say x plus 5 as an expression, but x plus 5 is equal to something as an equation. You have to remember that. So we have a question here. The Venn diagram below shows a survey of the days on which some students studied over the weekend. So let me just draw it quickly. So we'll have it. So this will be the universal set. This will be set 1. This will be set 2. So this is universal set. This is Saturday. This is Sunday. We have Ashley, Rick, Mike. Oops, that's not looking like a Mike. Mike, Josh, Emily, Hannah, and Ethan. Right? Now, question part A, part 1. How many students were in the survey? So basically, we just count how many names we have. 1, 2, 3, 4, 5, 6, 7. So we have 7 students in the survey, right? Now we have to say what it is. So it's not goat and sheep. We're dealing with the students. You have to put 7 students. It's like a unit. So if you were measuring centimeters, you put centimeters. If you're measuring inches, you put inches. Because we're counting number of students, you put students. List the set of the students in the survey. Okay, so Saturday would be the set Ashley, Rick, Mike, and Josh. Curly brackets. Now that is because they're within the circle that represent Saturday. Sunday, we'll have Emily, Hannah, Ethan, Mike, and Josh. And that's because they are still within the circle for Sunday. Right, so that means that Mike and Josh studied on both days. Part B, list the set of students who studied on Saturday. This is basically, oh sorry, what did I read? Part 2 is list the set of students in the survey. Oh, so what I did was wrong. The students in the survey would have been everybody. So that will be universal set. Sorry. So everybody in the survey would have been the universal set. So this would have everybody names. Ashley, Rick, Mike, Josh, run out of space. So Emily, Hannah, and Ethan. So see, sometimes you need to read the questions properly, right? I didn't read it properly. So they asked, list the set of students in the survey. So that's everybody. Now part B, they want us to list the set of students on Saturday and Sunday, which I just did. So let me just paste it back. So Saturday and Sunday. Part 3, list the set of students who studied Saturday or Sunday. One, we have a name on the outside, Jacob. Didn't see Jacob on the outside there. So that means I'll have to add Jacob here as well. Now, when they say or, it means you have to union the set, right? So when they say or, you have to union the set. So Saturday and Sunday, so Saturday union Sunday, I should draw that union sign in another color. Union Sunday will be everybody within the circles. So Ashley, Rick, Mike, Josh, Emily, Hannah, and Ethan, right? Because they are within the circles. Now Saturday and Sunday, the word "and" represents the intersection. So who studied on both days? Mike and Josh. So Saturday intersect Sunday will be who was in the middle of the both circles. So Mike and Josh. Now they want Saturday but not Sunday. Who studied on Saturday but not Sunday? Now if you study on Saturday and not Sunday, right? Only two people did that. That's Ashley and Rick. Now this would come like Saturday only. Right? So Saturday only would be Ashley and Rick. Part 6. Who studied on Sunday only? Now this is straightforward. Sunday only. Right? Sunday only would be Emily, Hannah, and Ethan. Emily, Hannah, and Ethan. And last question. Who studied neither days? So neither days. Now another way of saying this is Saturday union Sunday prime. Who didn't study those days? And the one person we have on the outside of the set is Jacob. So just to put everything in one screen, right? We have, see if I can enlarge it a little bit. Yeah. So these are the questions that they ask. And just to go over one more time, the first question, how many students were in the survey? My first answer would have been wrong because I didn't see Jacob on the outside. It would have been 8 students. 1, 2, 3, 4, 5, 6, 7, 8 Jacob. Right? The list the members of the survey will be everybody within this rectangular bracket. So Ashley, Rick, Mike, Josh, Emily, Hannah, Ethan, and Jacob. The members of this set who studied on Saturday, right, would be Ashley, Rick, Mike, and Josh. Who studied on Sunday would be Mike, Josh, Emily, Hannah, and Ethan. And Saturday or Sunday means either day, doesn't matter. So it'll have to be a union of both sets. So Ashley, Rick, Mike, Josh, Emily, Hannah, and Ethan. And if they put Saturday and Sunday, which is part 4, they ask who studied Saturday and Sunday or both days. The and represents the intersection sign. So who studied both days will be Mike and Josh. And if they ask us for something like Saturday and not Sunday, which is number 5, this is basically saying Saturday only. Who studied on Saturday only will be Ashley and Rick. Number 6, where they ask who studied on Sunday only, is be Emily, Hannah, and Ethan, because they are in the circle by themselves. And who did not study on either day would be the composite of the union. So that means who's outside the sets. So Jacob was outside the sets. Question 2, the Venn diagram below shows the survey for some respondents in relation to their preference of reggae or jazz music. Right, so again, just like before, how many respondents were in the survey? Now, this question is different from the previous question. This question didn't give us the individual names, but it gave us the number of people in the set, right? So again, universal set, set A, set B, 55, 20, 70, and 30. Let me change this from A and B to reggae. R is reggae, J is jazz. Right? So part A, how many respondents were in the survey? So basically, how many people in the universal set? Right? So the universal set will have 55, add 20, add 70, add 30. My maths is correct. 70 and 30 is 100, 120, 175. So 175 people. Right? Part B, how many respondents listened to reggae? Now, if you think about it as this section alone is 55, but we have to add the 20 people that listen to both, right? So don't need the lines in there. So the reggae will be 55 add 20, which is 75 people. Part 2, who listen to jazz? Similarly, jazz here is 70, but also who listen to both. So 70 plus 20, which is 90 people. Part 3, where they ask who listen to both jazz and reggae, is basically asking who listen to both in the middle, which is the intersection. So the intersection will have 20 people. For reggae or jazz. Now, when they ask for reggae or jazz, remember the or means a union. So how many people listen to music on the whole, right? So reggae or jazz. So the or turns into the union sign. It will be 55. Add 70. Subtract the 20. This is the formula. Right? Remember the number of elements in the union is equal to the number of elements in R, add the number of elements in G, subtract the intersection. Right? So this is the formula. Another way of writing it would have been the number of elements is equal to the number of elements in R plus the number of elements in G minus the number of elements in the intersection. So R intersect G. And all of these should have had the number of elements in front of it. Sorry about that, because we're dealing with the number of people in it. Right? Now this would be 50 plus 70 minus 20, which is 100. Right? So the number of elements that were in the union of the two sets will be 100 people. And they ask for the number of elements in reggae only, and the number of elements in reggae only. From previous examples, you would know that this is the shaded area only, which is 55. And part 7, who did not listen or who neither jazz nor reggae? So when you say neither jazz nor reggae, right? So the number of elements composite, right, to the union of R and G, right? So that is the outside. How many people on the outside? Right, so I just shaded the team. So we found that there's 30 people on the outside who didn't listen to reggae or jazz. So this would be 30. So we can make it a little bit bigger for you all to see.